Well, hello and welcome back to my workbench. Now on the workbench today we're going to be looking at another PS5 that does not work. Now this PS5 I did not purchase. It was donated to the channel by a gentleman named Mike. Thank you, Mike. Apparently this one is likely to be lightning damage because it failed during a storm along with some other electronics in his house, so pretty sure it's got lightning damage. He did take it to a repair shop and they, I think after about an hour, told him that it was a no fix. So not sure entirely what the other shop may have done or not done. I really don't know. But it's been sent in to me now, so we're going to take a look at it and see if we can, get any more life out of it. I have not plugged it in yet. That's probably step one. So let me get set up for that. All right, well, I have the power cord into it. I just want to see if the power supply is starting up on it or not. So if I flick this on, that looked odd. I'm not quite sure what that means. That did not look like a normal startup of the power supply. It's usually a pretty good surge, but it did try to start up. So, probably gonna need to get down to that power supply and see if it's putting anything out. I can't tell why that does not look normal though. It definitely was not a normal startup of the supply. Let's get some covers off and get down to business. Well, as I'm taking this thing apart, I'm seeing a lot of moisture. Can you see it down there? See the droplets on the walls there? I don't know what that is. Or is it oil? But I just see little droplets everywhere, and I'm not entirely sure what it is. That looks like corrosion right there on the heatsink. I'm not sure what we're going to find in here. Let me get it further apart. Alright, so I've got the side plate off the cover enough here so we can actually see if we're getting 12 volts or not, because I am kind of curious about that. Let me go ahead and connect power. And let's just see if we check on this 4-pin for the disk drive. And it's one of these on the end. I never can remember. Let's try this one. I got to turn the power on. 1.38. That looks like a power supply that is starting up and dying is what that looks like. I'm turning the AC power, the voltage on and off. I don't believe that power supply is working. Let me make sure what kind of level, what kind of resistance do we have right here. Power is off. That's in the mega ohms there. And that's in the K ohms. I don't see a short on a 12 volt rail. So let's get down to this power supply and just see if it's totally dead. Well, our power supply is out and I have my load connected. I need to turn it on. Right. And let's just see if this thing will do anything. Give it some voltage. That's not good. 1.4 volts. Turn it off and back on, but that's no good. Okay. So we have a dead power supply, or well, it's rather dead. but you would think the shop would have tried another supply. So maybe they did, and there's other problems, I'm wondering. So that's the first thing I'm going to try. We can fix that power supply, but here is a repaired ADP400FR. We will put that in that chassis and see if it will turn on then. Probably not, but we'll give it a try. All right, well, my spare supply is in there. We're ready to find out if there's, any hope for this board. Power is connected, fans connected. I just got the ribbon for the on-off and the LED hooked up. That's all we need at the moment. Let's see what happens. That supply started, I believe. Do we get a beep? Well, it won't beep for the eject button because there's no drive right now. Will it turn on, though? Beep only. No fan and no light. Single beep. Okay, does that sound familiar? Mike did mention that he had this plugged into some kind of an HDMI hub, I guess for switching, rerouting the HDMI signal or switching between different devices, and other devices on that device were damaged. So I'm going to say it's very likely that we have a dead HDMI encoder, right about in that area. Because a dead HDMI encoder would give you that single beep with no lights. So, okay, two problems then. Dead power supply and dead HDMI encoder. That's where my guess is right now. Let's get this shield off and get down to the circuit board. All right, let's take a quick look around this board if we could, specifically in the HDMI encoder area, as that's where I suspect our problem is. Right in here. There's no hole in the HDMI encoder, but just in case, I want to take some quick diode checks around there, just to see if anything jumps out at us. I'm going to be checking on some of these little tiny capacitors on the different rails. Wow, okay, that's pretty short. Both of them were short, wow. I'll put it in resistance mode so you can see how low the resistance is. Let me short these leads out. Null that out. And this is one of the little tiny bypasses. I can't, this is either, it's either going to be a 0.9 or 1.8 volt rail. I'd have to look and see what it was. 1 ohm short. And right beside it, there's another tiny little capacitor. It's on a different rail. Well, if I can get it to give me a reading here. 0.18. 0.18 and 1.32. That's just a little bit short. Okay. When I'm taking this thing apart, you can tell as you take this cover off, all these little pads, adhesive, conductive, paste they use. This thing had never been apart. So whoever worked on this, I think tried another power supply, and then it just beeped, and they said it's a no fix. That's my theory, because it didn't feel like, as I took it apart, it was like it had never been taken apart before at all. This stuff, it put up a fight, This put up a fight getting off, so it had never been removed before. So I think we need an HDMI encoder. I know I don't have any new ones because I keep forgetting to order some. I do believe I have one, one owner, low mileage. Where is that part? I'll find it. I think I have one on hand. I could pull from a donor board. These are donors that I'm going to be finding eventually when I find it. But let's get set up and get this encoder changed out. and I'll bet you this thing will work. I got a gut feeling. I got a good feeling on this one. Needs an HDMI encoder and she will work. All right, well, our HDMI encoder has been replaced. That went pretty well, I think. And I did take a quick check with the meter, and the shorts are gone now. There's no more shorts on these little, if I can get you close enough, those little tiny capacitors right here was where I was checking. Those two right there. So I want to give some voltage to this board and see how much current it draws, see if it looks somewhat normal. I'm going to give it 12 volts at half an amp. Maximum, let's see what it does. Yeah, 300 milliamps and come back down. That looks totally normal and healthy. All right, so let's slip this back into the chassis along with my spare power supply and see if we have any more life then. I'm thinking we will. All right, well, I have slipped it back into the chassis, the board with my spare power supply. Let's see if she will try to turn on. Oh yeah, fan spin, we have a light. Can we get some video? Well, after a storage check. I'm sure there'll be a storage check. Come on. Still blue light. It's thinking real hard about doing a storage check right now. Come on. Still a flashing blue light. So we now have a continuous blue light of death, do we? Nope, look at white light. White light. No video, but we have white light. Okay. All right, so we may have lost something else in the HDMI encoder area. I bet we did. I did not look at it. I hoped it was just the encoder. But we may very well have lost something else. You know, the 5 volts that goes out. It could be a lot of things. So we need to take a really close look around the HDMI encoder. So it's doing a reboot. It just did a storage check. So I'm going to let it finish that. And I'll shut it down. I did not look at the HDMI port. It didn't seem loose. I doubt it's the port. It could be the port, but most likely, we probably have some shorted Zeners around this port. There are several 5.6 volt Zeners on several lines, and one or more of those. I have not looked. I usually would plug in a breakout board and check, and I did not do that, so that's on me. So when it gets through doing its storage check, I will unhook it. We'll get it back over on the bench, and we will plug in a. Oh, I don't have a clamp on it either. The fan's ramping up. Yeah, I kind of forgot the APU clamp in my excitement, in my exuberance. So now I get to burn my fingers for a little while. It's a small price to pay. All right, so we're back over on the workbench. I was able to shut this thing down. Normally I couldn't record it because I had run out of hands. I was holding pressure down for the APU and holding the power button, and it actually did beep and go to a white light and shut down normally. So hopefully we haven't corrupted anything any further, but we do need to take a closer look at this HDMI port because we still have something wrong there. I do think it was kind of odd. It seemed to have caused a continuous blue light of death. Possibly because the HDMI circuit was not responding properly. I don't know. So we're going to take some diode mode checks looking into the port and check every pin. Say pin 1, that looks normal. 2 is ground, 3 looks normal, 4 looks normal, 5, 6, 7, 8, 9, all that looks normal. 10, 11, 12, that looks normal. 13, 14, 15, 15 seems a little low. 16, 17 is ground. 18 and 19. Okay. I'm wondering, go back and look at 15. 15 seems a bit odd to me, just with the way it's changing there. No, I'm reading diode readings in the other direction. I need to get another board out and compare it to it. Do I have another one nearby with an intact HDMI circuit? Possibly. Let's look at 15 here. Yeah, like a 0.7. That sounds more right. 16 is also 0.7. 18.54, I think that's normal. That's there's a Zener. You're reverse biasing there, I believe. 19.7. So 15 and 16 both read right at 7/10. And if I check on this board, the one we're working on, over here, 15 is a little low, and 16.6. So we need to look at those closer. They're not way off. Let's just do something. Let's just for the heck of it, let's do a resistance check. What do you think? I'll put the black probe on ground. 15, 1K ohm. 16, 1.1K. What about over here? Okay. 15. Ooh. Reads in the megohms. 16. Also in the megohms. Interesting. So yeah, we need to take a closer look at 15 and 16. You know, likely the Zeners that are on those particular pins. There's a Zener back here. There's a regular diode. There's some Zeners scattered around over here. Let me get the microscope cranked up and see what we can find. All right, we're going to be taking a look under the microscope in the area of the HDMI encoder and see what's going on with it if we could. Now, the readings on the port weren't terrible, but they weren't quite right. If you remember, on 15 and 16 both seem a little bit low. So let's focus on 15. Or what about 19? 19? Not sure about that one either. This Zener here, I believe, is on 19. I'm going to put my probe on 19 down here on the breakout. Yeah, so that's on 19. Okay. What about, let's go to the other side of the board. I'm interested in what's on 15 and 16. Let's see. Which one of these is on 15 and 16? Let me look again on the other side. This is the IC which controls the 5 volts going out to pin 18. And I did find it odd. I was checking. If we check with in diode mode, red probe on ground, this is the output that goes to pin 18. Let me put my probe on 18. Yeah. So this is the 5 volt switched output that goes to pin 18 of the HDMI port. And if we check, you know, the way you normally check a diode check, red probe on ground, we're reading half a volt. But if I reverse these leads and go right here, I get 1.5. That's black probe on ground. And I think that's unusual. Let's compare that to another board here. All right, quick like. Let's compare that to this board. Again, I'll put red probe on ground and check right there. You know, if I can get a good ground connection, there we go, 0.54. And if I reverse it, this is now a black probe on ground, red probe on the test point. We get no diode reading. So I get the feeling something has broken down there. So go back to our board. I'm suspecting this 15JL chip because it is, you know, directly connected to that port. It's what switches the 5 volts out. And I think it's subject to get popped by lightning if lightning comes its way. And I think, let me check something. 15 and 16 maybe over here. There's 15. Here's 16. And they both tie to this 5 volt out through pull-up. These are, I believe, 1.8K pull-up resistors. So, I think that's a good place to start. I have these new chips. Let's just swap it out. I don't think I've ever had to replace one of those. There's the first time for everything. Let me find my 15JL. There could be other parts there that do the same thing with different part numbers, but they should be functionally the same. JL, there they are. TPS 2553. I have looks like I have 10 of them, and I've never used them. But I think I am going to replace that one and see if anything changes. Pin 1 is in our lower right there, I believe. Let me go ahead and get one of these chips out. All right. Brand new one, ready to go. And it could still be a Zener. I'm just kind of playing a hunch here, I suppose. add a little leaded solder there. Everything's better with a little leaded solder. Now if I can find my new chip, it decided to go airborne. Okay, let me shake the board here. There it is. It was way down at the back of it. It had traveled some distance. That looks like that should work. Let me touch them up a little. We'll let this cool off just a little bit and do another diode check. Curious if that reverse reading has gone away. Let's see. Red probe on ground. Looks normal, 0.5. And the other way, no, we still got that 1.53. I don't think that's normal. I don't think that's normal. Could be wrong. Doesn't read that way on the other board though. I think, oh, I thought it was on the other side. I think I want to lift this zener right here. Right there. We should see that same reading right there. 0.5, and if I go here, 1.5. That's with black probe on ground, red probe on the end of that zener. I don't think that's normal. Could be wrong. Let's lift that zener. Maybe I'll add a little solder to it, make it easier. Okay. All right, what about now? Red probe on ground. If I go right here, 0.48, and if I reverse it, still got that 1.5. Is our zener totally fine? Possibly. This doesn't seem like that's normal though. Alright, so where are we on this board? Well, I've been chasing something which may not be a problem, but I can't help but feel that it is. And that is on this output of this, I see the switch is 5 volts to pin 18. I see 1.5 k ohms to ground, 1.76. That's with the black probe. I'm in resistance mode, black probe on ground. And on every other board I have, I can check, I get in the meg ohms, like 30 meg ohms. So I just don't think that's right. And I think it may be something we need to chase it down. Now, I see a tiny capacitor right here that's going to ground. That's a possibility. I don't believe it's over here, though, because, like I said, I've got 1.76 here, right? These are 1.8K resistors. So you'd have to have a short on the other side for that to cause, for one of these shorted Zeners over here to cause that. And we don't have a short over there. We have in the K ohms, right? Which actually should be much higher than that also. So my feeling is either this capacitor or on the other side of the board, right there by the port, we have another one right here. Has that broken down? I don't know. See if we can remove one or both of those and see if that resistance goes away. See if I can turn this around where I can get to it a little bit better and see if I can use my hot tweezers to get that off. See what happens here. There we go. Maybe I'll park it right there. All right. Now, is that 1.5 k ohm resistance gone? Has it changed in any way? Black probe on ground, red probe right there. No, did not change at all. Okay. Maybe I'm just totally crazy and there's nothing. There is no problem. It just doesn't feel right though. Take this one loose. Probably should have put some flux on it. Maybe not that much, but oops. Where'd it go? Where'd it go? I think it's gone. Okay, did that change anything? No, still 1.76. What gives? Still have that same reading right there. Pin 18. I don't get it. Let me remove this chip, just for the heck of it. All right, now what's our reading? 1.7. It didn't change. Lift both of these zingers. Park that one right there. Spin that one around. Now what do we read? Well, we've gone, oh, in the megohms. Yeah, 2 megohms. So one of these Zener's broken down. That measure 1.2. Let's put this in diode mode. .9, and that's in the reverse direction. 0.62. So that one has broken down. I have a feeling both of them have broken down, and that's why I was getting this reading. 0.9. That's with the red probe on the cathode. What about this one over here? 1 volt. Yeah. Excuse me, I keep bumping the microscope. 0.68. Yeah, they're both broke down. So yeah, pretty good strike. But they're not shorted. They're not dead shorted, but they are broken down in the reverse direction. If you look at that, this is the red probe on the anode, and you get like a 0.6, which is normal. But then you reverse them. Red probe on the cathode, 1 volt. That's not normal. So I need to replace both of these Zeners. And I think I'll go ahead and replace the one I took off earlier. Yep, I need to replace this capacitor that I lost. I'll pull that from a donor, no problem, because I don't know the value of it. It was probably a 0.1, but I don't know. Okay. Yeah, all right. Let's replace a couple of Zeners, put this chip back, put some capacitors back. Maybe ready to test. right, so our Zeners have been changed out. Let me get a close-up view. Zeners have been changed out, which were right in here. That one and that one. This chip is replaced to 15JL, which is the switch for the 5 volts. Changed out this Zener. Replaced the capacitor that I lost over here. And if you're interested, there's the parts. There's the Zeners I've been using. Just some good 5.6 volt Zeners, the right physical size. And there they are. There's what I removed right there. 3 Zeners and that one 15JL switch IC. So I think we're ready to put this back in the chassis and see if we have a picture this time. I hope so. All right, the board is back in the chassis. It's time to see if we've done any good. Blue light, fan spin, all good things. Can we get a picture this time? Oh, there we go. There we go. All right. So yeah, that lightning did a little damage. It was interesting to me that with those Zeners breaking down that we had a continuous blue light of death there for a while. I have to make a mental note of that one. All right, I think we're going to be good here. I need to do a few more checks on this thing. And we had to fix a power supply, don't we? Or I could just leave my spare one in there. Nah, let's fix a power supply. Let's fix a power supply. This video may be too long though, so yeah, it is what it is. But this looks promising. Let's tackle that power supply next. All right, well, our main board seems to be repaired. We got video, so let's see if we can tackle this power supply, shall we? Maybe this won't take too long. Maybe. Get the antenna off. Just, there we go. Should just pop right off. Get you out of the way. Find my Phillips. And please do not open your power supplies because there are dangerous voltages inside. So please do not do what I'm doing unless you are very well versed in high voltage, because these things can hurt you. There we are. And I'm going to handle this carefully because we do know it has had power in it. And it was trying to run. It had, it was putting out, I don't know, 1 volt or so. So there's probably going to be some residual charge on these caps. Let's get rid of that. First thing. Positive and negative. Yeah, she had 30 or 40 volts there, so. All right. So that should be safe. Ooh. And we have a hole in one of our chips. Right here. I believe that's the DNP014. Which I do have some of those, if that's all it got. Probably gonna be very lucky if that's all it got. Not sure how well that's showing up on camera. But yeah, there's a ventilation hole opened up. All of the magic smoke has escaped. Just wonder if that's all it got or not. I'd be surprised. So this surge came in through the console back through the power supply, because this is the cold, or the console side of it. The AC line side would be over here. You can see the dividing line right here. This is your hot side, this is your cold side. So it came back, basically through the HDMI port, through the into the chassis, and through the power supply, would be my guess. So yeah, that should be the DMP014, which I think I do have some of those. I bought some as soon as they were available. Is it 014 or 015? No, it's 014. There we go. Looks like I have used 2 of them so far. I think I ordered 20 when I ordered them. So let's get our microscope awoken. There you go. Yep. Kind of neat. You can see the actual little dye in there, can't you? Kind of neat. Anyway, it's done. Let's get it changed out. It's kind of interesting that it was working, just putting out like 1.5 volts. I'm ready. I got my hot air at 370. I try to be careful with these boards. They will popcorn on you. I think they're just regular, like FR4 fiberglass. And they will popcorn on you. There we go. Got that out of the way. Bye-bye. Let's see. Yep. Let's turn it around. Oops. Come on now, cooperate. All right. What are the chances that's all it got? Could be. Could be. Let me get set up and we'll get this thing hooked to the load. Well, the dummy load, my DC load is connected. I got the polarity right, I believe. Get it in focus. Yeah, positive is on the inside, negative on the outside. Don't want to get that reversed. I don't think my DC load would like that too much. I am metering across the filter capacitors there because I worry about that voltage going too high and those capacitors blowing up in my face, which is always a possibility. And the load is on. Let's just see if she will do anything. Let me get this meter a little more in the picture. I'm going to flip the AC voltage on over here. Focus. Work with me, camera. Nope. 1.4 volts still. You see that? We got up to 398 there. 1.4 volts coming out over there. Okay. So we got some more lightning damage. Is our DAP 053 dead? That's a possibility. Or one of those little tiny MOSFETs around it could be. Let me get this thing discharged, get the caps discharged, and we'll dig into it. All right, I think I'm ready. We're going to do a quick check around this DAP 053 to see if it has a shorted input, possibly. It's not a guaranteed thing, but you know, with lightning takes whatever it wants. Pin 1 is over here, I believe. I have discharged the capacitors, by the way, so it is safe. 2, that looks good. 3, 4, I think it's ground. Nope. Am I on the wrong pins? I'm trying to remember. I can't really see where pin 1 is. I think this is pin 1. 1, 2, 3, 4. That doesn't seem right. 5. I thought we had a ground over there somewhere. Where are my notes? Where are my notes? I don't know. Sometimes they wander off. So, red probe on the ground of the large capacitors. Yeah, pin 4 is supposed to be ground. So am I looking at this backwards? 1, 2, 3. Okay, I must have been going to say, I'm pretty sure pin 4 is ground. Why am I not seeing ground there? That looks better. 5, 6, 7 is open. That's good. 8, that looks normal. 8, 9, 1.12, it's got 10, 11, a little lower than usual. 12 is no connection. 13 looks fine. 14, 15, 16. That all looks pretty good. So, do we have something else damaged over here, which is where the the control loop controls the voltage feedback to this chip? So that's a possibility. Or do we have a partial shutdown going on? Let me look at some diode some Zener diode readings, not Zener, some diode readings around these opto isolators here. That looks all, nothing jumping out at me there. And the most likely thing is something over here, since we're isolated optically here, and the transformer for the main voltage. So, what if I measure around? Do I have any notes? I think I do have some notes on the DMP014 readings. Yes, yes I do. Do I have it turned the right way? No, I don't. All right. Pin 1 here. We got to find the cold ground, which I think we can get probably right here. Pin 1. Ooh, we're not starting off good. That should be 0.674 or 647. And we have a 0.08. Let's just keep going. 2 looks normal. 3, 4, 5, 6, 7. I need to swap hands here. 8 is ground, that's normal. 9. Yeah, there's a good bit of capacitance on there, that's normal. 10. 11 is like 0.174. That looks good. 12, 13, 14 is shorted to ground and should not be. That should be 0.616 on 14. So 14 and 1, we need to take a closer look at. I really need to look at 14 since it's seems to be a dead short. All right, let me get the microscope cranked up. Let's take a look at that area. Let's see what we see. I'm going to guess a Zener possibly in that area. Zener, or I don't know, perhaps the opto-isolator? I don't know. All right, finally get my microscope to play along. So let me get this in focus. Pin 14. I'm not sure what's connected to pin 14. Perhaps we can follow it around, because something is shorted. Chip should be good unless it got, it could have gotten damaged when I replaced it and fired the thing up again, but maybe not. 14. Round through here. Looks like it goes under this capacitor. It goes to right here. Over here. If I don't lose it, there's some flux there. Goes there. I'm losing it under that resistor. And I'm losing it under that resistor. Let me clean that up a little. Get rid of this flux. Okay, let me switch to continuity mode. Put a probe on 14 down here. So it goes here, 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 under the capacitor. And I'm thinking under this capacitor up there, yes. To a resistor. And another resistor over here. And we're shorted on this side too. This must be a low value resistor. So high resistance on this side of this resistor, low on this one. So let's go the other way. There's a capacitor here. And we have a capacitor here. Still got a short. I don't see it going anyplace else though. Shorted here, shorted here, shorted there. Oh, but it does, it goes there. Yeah, that's how it goes, yeah. Here, there, there, down to here. So, a capacitor? Nothing on this side of this capacitor. It's all on this side. Yeah. This is 0.18 on this side. 0.31 on this side. So it's lower resistance on the top. 0.18, 0.19. And like it's not the other side of this resistor. It's not that. That's, infinite. So all that really leaves, well, I mean, let's face it, pin 14 could have shorted internally. or we have a capacitor that's shorted here. And the only two I see, let me go to ground here. So we're connected here. All right, now there's ground on that side of that capacitor. This is pin 14 coming up here, under here to right there, and this side is ground. So if this cap were to short, that could do it. Otherwise, we go up here, there, 0.23, 0.36. So no, it is lower. I was looking at that wrong earlier. Okay, this is going to be ground right here, I do believe. All right, let me take pin 14 off. Let me take that chip off. Just make sure it's not the chip. Although it is a brand new chip, I really don't think it's the problem. I would like to isolate it. Okay, that is off. Probe on ground. Still shorted. About 0.7. 7/10 of an ohm. I'm going to lift that capacitor right there. Sit right there. Right there. Now, black probe on ground again. Hey, our short is gone. Our short is growing. I'm still in continuity mode. That capacitor has died. We go right across it. Yep, that's it. So I have no idea what its value was. Probably the same as this one right here beside it. But she is shorted. Okay, that's good to know. Our chip is still good. That is C139. C139. What is C139? I don't know. Okay, so we need a capacitor to fix this thing. And I happen to have a 400 FR I've been stealing parts out of. I keep intending to fix this thing one day, but I keep stealing parts out of it. Sometimes you just need an odd capacitor. You can see I've made a note of everything I've stolen out of it so far. So yeah, but anyway, it's going to get stolen from again. Let's get this thing open and we'll steal that capacitor and see what its value is. Well, we'll check the value while we're in here. So here is this donor. We need C139 out of here, because I also like to know its value. So maybe I can replace it someday. And maybe some flux would be nice. So what I want to do right now is just kind of move it to the side so I can get a reading on it. There we are. Let it cool off a little. And I'll take some smart tweezers here. See if I can get a reading on it. Alright, may still be a little warm. Let me check. 1 nanofarad exactly. 1.00 nanofarad. Okay. 1 nanofarad exactly. That's what it says. Okay. I'll have to write that down. So for right now, I'm going to steal it. Yep. Gonna steal it. Now, where does it go? Where does it go? Up here. Got it. Get that DNP014 back on there while we're here. If I can get it lined up without bumping it. Okay. All right, what do we think? Let's get set up and check it again. All right, now what do we have? I'm again metering the voltage across the filter capacitors there because it's in my best interest to monitor that so I don't blow those capacitors up. The load is connected. It is on. Let's see what we get this time. No. 3.4. We went up. We got something else. We got something else. Another shorted cap. Zener? I don't know. Got to find it. So we still have a problem. Still have a problem. So I have broke out a known good ADP 400FR board to make comparisons against. And I may have found something. I was looking around, well, the DNP014 and around those opto isolators. And I think it's, yeah, pin 1 of this ADP 400 and 80 this DNP 014. See if I can get on it here. .59, let's just say 5.6K. Okay. Now let's go to that same pin over here on this known good one on the right here. 1.49 mega ohms. So yeah, there's definitely an issue there. And I think I'm seeing something similar on one of these opto isolators. Which one was it? This one? Yeah, 5.6 k ohms on pin 2 of this opto isolator. And over here, it's the same circuit, I'm guessing. Right there. Yeah, 1.49 mega ohms. So, bad opto isolator, possibly. But I believe I'm also seeing another capacitor down here on that same circuit. Right. Let me see if I can locate it. This one right here. Yeah, 1.57 k ohms. I can measure right across that cap. One side of the cap is ground. 1.59. And if I measure that same capacitor right here, 132 k ohms. So that's a big difference. So I think I'm going to just go ahead and lift this capacitor and see if we get a major change. I'm assuming like pin 1 here is connected here. Yeah, it goes right to pin 2 of that opto isolator. Is this capacitor in that same circuit? No, it's not. So I'm not sure why I'm getting that low reading there. It's either the opto oscillator or this capacitor, which the capacitor is not in the same circuit, but it does read low across it. So what to do? I mean, diode mode, this opto oscillator looks absolutely fine. Should get about 1 volt. Looks fine. What about reverse? 1.75. And if I check this one, right here, nothing. There's 1 volt. That's forward. And if I reverse it, 1.77. Was that the same as I had over here? Reverse. Yeah, very similar. Diode readings look similar. It's resistance readings that look different. So, yeah. I think I'll start by lifting that capacitor and just see if the resistance reading across this point changes significantly when I do that. 1.48K compared to 126K. Let's start there. Let me get the microscope cranked up. All right, well, here is this capacitor that I was looking at right here. I think I am going to go ahead and lift it. That may not be it. We won't know till we lift it and see if it changes. But there is definitely a low resistance across it. Of course, it could be something in parallel with it. Always a possibility. Park it like right there. All right. Now what do we have resistance wise across where that used to be? Still 1.3K. And the capacitor does read wide open, so it's not that capacitor. Okay. $1K to ground right there. And 5.891. So do we have an opto isolator that is bad? $5.2K. This is compared to this other board right here. One and a half meg, 3K ohms. Well, that's a little ambiguous. $155K right here to ground, and over here 16K ohms. 16K ohms. Because what I'm looking for is where there's a parallel path here, like which is looking like the chip itself. 16K ohms. What is this capacitor here? 16K ohms right there on C141. Where did it go? Where did it go? All right, there we are. And of course, if I measure right here, a short? Oh, that must be ground, sorry. Yeah, 15K ohms, 15.58, that looks fine. Yeah, and this side is ground. Okay. So that's ground. What is this? That's not related. What about this opto isolator right here? What about it? There we are. That's clear. What do we measure across this optimizer now that it's lifted? 1.8K ohms. This opto isolator has broken down. IC51 has broken down. Okay, and back over here, 129K ohms. 129 k ohms where that capacitor was. So it was this opto-isolator. EL1019. I think I have some of those. Yep, 1.8K across it. This is across the, of course, the collector emitter side of this opto-isolator. This should be the LED over here where pin 1 and 2 are. But there's definitely nothing turning this on right now. There's no power on the board, so this should be infinite. Okay, let's get that swapped out. Alright, we're ready to test this again. Load's connected. What's it going to do this time? About the same thing. 3.3 volts. Still not working. Great. Alright, we got more damaged components. Alright, where are we now? Well, I have been chasing a low resistance on pin 1 right here. About 5.5 k ohms compared to ground. And you know, the other board, the working board, measures like 4.5 meg ohms there, but I had 5 k ohms. So that connects straight to this opto-isolator. I have changed out this opto-isolator. I've also changed out this opto-isolator. It did not help any. But I got to noticing, if you look right here where it drives the opto-isolator, right there, it also splits right in there under this labeling, under that paint. It goes up here to there, and also to this capacitor, and to ground. This is ground over here. And if I went across this, I measure about 120 ohms. That capacitor has broken down. It hasn't shorted completely, but it is broken down to 120 ohms. So we need another capacitor. And you can see I removed the DMP014. I thought maybe I damaged it during testing, but I don't think so. Another bad capacitor. So let me swap this out and put a DMP014 on there and see what we have then. All right, then, with that capacitor swapped out with one from a donor and reinstall the DMP014, I have my load set up over there. I am metering right across the output terminals here. Let's see what we get if we get some AC voltage into it. 11.91. And yeah, we're dissipating 95 watts back there. I think that will work. I think she'll work. Let me put this all back together and we'll put it back in that chassis and just see how well it works. Well, this PS5 is fully reassembled with our repaired power supply and our repaired HDMI circuit. I'm installing a game off a Blu-ray drive and it seems to be doing just fine. I'm going to let it run for several days and make sure she's good, but looking pretty good right now. And I want to thank Mike for sending this in to me and donating it to the channel. And it was a challenge. I had a lot of fun working on it, but it was a challenge. And if you enjoyed that challenge, please just let me know by giving me a thumbs up. And I will see you in that very next repair. So long for now.